Hello friends, welcome to Cadence tutorial. I am Madan Kumar Jha and today I am going to explain how to make a Pass Transistor Logic circuit using PMOS. Okay, so first of all, I have to make a schematic of a Pass Transistor Logic using PMOS. So for that, go to File, then go to New, then in Cell View, you have to give the name of that PMOS and PTL. So I want to make a Pass Transistor Logic using PMOS, so I name it PMOS PTL. Okay. Then after creating the cell view, you have to extend the PMOS from GPDK library. So press I, then in GPDK 180, you will get PMOS. So hide it. No. First I have to search about PMOS. So this is PMOS. Then hide it. I want to rotate this PMOS for making good looking schematic. Then actually, the VTH of a PMOS is basically negative, so I have to apply the negative gate voltage to turn on this PMOS. So for that, I am going to supply this PMOS with mm, gate with negative voltage. So for that, what I can do? So if I will give a ground terminal to the gate, and positive terminal to the source of this PMOS, then it will automatically uh, become negative. Okay, so I'm going to rotate it, then connect this ground with the gate of this PMOS. Then the source of the PMOS should be positive. If the source will be positive and gate is ground, so VGS will be 0 minus 1.8, that will be minus 1.8, so it is basically lesser than the threshold of the PMOS, which is approximately minus 400 millivolt. Okay, then our PMOS will work. Okay, so I have to supply this gate source of the PMOS to 1.8 volt. So again I'm going to drag the source voltage VDC. Okay, now I have to specify the DC voltage to 1.8 volt. Then escape, I'm going to copy this ground and then rotate it. So now for connecting this to terminal, I am using W for wire. Then I have to connect the body of this PMOS to 1.8 volt. Actually, I have already uh, tell that the body of the PMOS should be connected with 1.8 volt in my previous lecture, so you can go there. Okay, now I want to check the output of this PMOS. So PMOS Pass Transistor Logic. So I have to create a pin W, no P, and then change this to output, and then hide it. So it will be our output pin. Okay, then connect this pin with the drain of the PMOS, and I also have to create a input pin. So I'm going to change the direction of this pin to input and give its name as A. Okay, then hide it. Okay, so this is my input pin. Now I'm going to connect this to. Okay, so this is the schematic of a pass transistor logic using PMOS. Okay, actually I have given here DC voltage of 1.8 volts. Sometimes it occurs in cadence that when we initially give 1.8 volt to any MOS, any PMOS or NMOS, then it might charge. There may be a parasitic capacitance which will charge to 1.8 volts suddenly and then it will not drop. So first I want to give any initially voltage to 0 volt to the source of this PMOS. So for that I can use B pulse here. So I'm going to delete this. I'm going to use pulse voltage. So again in instance I'm going to change this VDC to B pulse. Okay, and then in symbol I'm going to set this voltage 1 to 0 and voltage 2 to 1.8 volt. Okay, but it might work here because here DC voltage also we can use. It will also work because the gate of this PMOS is connected to ground, so there will not be any problem. Okay, if but in NMOS that problem will occur. Okay, so escape. Now save this schematic. So everything is correct. If everything will be correct, then there will be no errors. So there is no errors. Okay, then go to ADL, edit, and give it to 100 nanosecond transient time, then moderate, then okay. Actually I have made some minor change because I haven't give any period to this pulse voltage, so I am going to give the period of 10 nanosecond and the pulse width of 5 nanosecond in schematic of this PMOS PTL. Now I'm going to check and save it. Okay, and then again I'm going to ADL, and in output section I have to select the output. So this is basically my input and this is my output of first transistor logic. So I'm going to select it, then press OK. So everything is fine and run the simulation. So you can see this is the output of the pass transistor logic. So basically the PMOS pass transistor logic passes 1 uh, strongly and passes 0 weakly. So you can see when our input voltage is 1, then the output voltage is also 1, but when our input voltage is 0, the output voltage is 265 millivolts. So it pass 0 weakly. Okay, but passes 1 strongly. So thank you. This is all about fast transistor logic using PMOS.